Hello student, this is Ashish Vegadwa from Electrical Department. Today we will learn Scr Protection in the subject Power Electronics. Let's move to the content of this topic. In this topic we will learn classification of protection circuit, di by dt protection, dv by dt protection, overvoltage protection, overcurrent protection, and last we will learn electronic crowbar circuit to apply overcurrent protection. Let's see what are the classification of the protection circuit. Protection circuit can be classified as di by dt protection, dv by dt protection, overvoltage protection, overcurrent protection, etc. Protection of SCR is necessary because SCR are very delicate device, and so they must be protected against abnormal operating condition, and various protection are listed above. Let's start with the first protection, that is di by dt protection. It is a rate of current. It means current may be increase or current may be decrease, and we have to provide protection against increase or decrease of current. This is the circuit diagram to provide protection against di by dt. So when SCR is forward bias and it is turned on by applying gate pulse, then anode current will flow through it. So a current will flow from the supply to the switch to the SCR, and across we have connected one resistor and capacitor, and this resistor and capacitor are Snubber circuit, and series with it we have connected one inductor, and current will come back to the circuit. So anode current requires some time to spread inside the device. It means charge carrier will spread at junction of the SCR. But if rate of rise of anode current is greater than spread velocity of charge carrier, then local hotspot may be created on the junction, and due to very large amount of heat and large amount of current density, and it will cause heating of the junction. It may be damage the SCR, and to avoid this kind of heating we have to use inductor in series with the SCR, because inductor is device which opposes the rise of current or fall of the current. So by using inductor in series with the SCR, we can provide di by dt protection. So for that we have connected one inductor in series with the SCR. Let's see the next protection, that is dv by dt protection. d by dt is the rate of change of voltage across the SCR. It may be rise of voltage or it may be fall of the voltage. Let's see the circuit diagram of the dv by dt protection. So here we have used one resistor, one capacitor in parallel with the SCR. Let's see the equation for current which passing through this capacitor, that is IC is equal to C into d by dt. It means if d by dt is high, then IC will be high. If d by dt is low, then IC will be low. And higher value of IC may be turned on the SCR even if we have not applied gate pulse. So it is a false triggering of the SCR, and to protect SCR from this false triggering we have to use Snubber circuit. This is also called a Snubber circuit. Let's see Snubber circuit in detail. Snubber circuit is a combination of resistor and capacitor which is connected parallel across the SCR. So this is the circuit diagram of Snubber circuit. This resistor and this capacitor are connected across, it means parallel to the SCR which we have to protect. This capacitor is used to limit the d by dt across the SCR, and this resistor is used to limit the high discharging current through the SCR, and this resistor is used to current which passing through this capacitor while discharging or charging period. So if this switch is closed, it means this SCR is turned on, this capacitor will behave as short circuit. At that time voltage across this SCR will be 0. If the supply voltage is very high or it may be low, then which oppose the rise of voltage or fall of voltage across the SCR. So this how it can provide protection against d by dt. Let's see the next protection, that is overvoltage protection. First let's see how overvoltage will occur in the system. There are two reasons by which overvoltage can occur. The first reason is internal and the second reason is external. Let's see each of the reason in brief. The first one is internal overvoltage. Suppose we have used one inductor in the circuit, then reverse recovery current of the SCR decayed at very fast rate, then it is a high di by dt, or if decayed at very low rate, then it is a low di by dt. So due to this di by dt, overvoltage surge is produced with magnitude is very large, and it is due to inductor of the circuit. Due to lightning stroke on the line, this overvoltage may be occur in the circuit. Or another reason is that if very large amount of current will pass through this circuit, then if we interrupt this current, it is also reason to cause the overvoltage in the circuit. Effect of this overvoltage can be reduced by snubber circuit, non-linear resistor, and other clamping device, etc. In SCR, due to overcurrent, the junction temperature is exceeded than the rated value and the device may be get damaged. Overcurrent is interrupted by conventional fuse and circuit breaker. Generally, this conventional fuse is provide overcurrent protection, whereas the circuit breaker is provide overload protection. During faulty system, overcurrent will flows in the circuit. If the value of load is very large, then overload in occur in the circuit. So during short circuit, we have to use conventional fuse, and during large amount of load, we have to use circuit breaker. Suppose if fault in occur, then this fault current must be interrupted before the SCR get damaged, and only faulty branch of the network should be isolated. And this circuit breaker has required long tripping time. Circuit breaker having a high tripping time compared to conventional fuse. It means circuit breaker require more time to trip than the fuse. So this circuit breaker is used to provide overload protection, and the fuse is used to provide short circuit protection or overcurrent protection. Let's see the electronic crowbar circuit to provide overcurrent protection. So this is the circuit diagram, electronic crowbar circuit. First we have used one fuse, after that having one power converter, and it is connected with the one load. This power converter may be rectifier, inverter, cycloconverter, AC voltage controller, etc. And across this power converter we have used one SCR, and to provide gate pulse to this SCR we have used gate triggering circuit, and this gate triggering circuit will operate on the basis of current will pass through this line, and this gate triggering circuit will operate on the basis of this current sensing device, and this current sensing device will sense the current will flows through the load. If the value of current flows through the load is normal, then it will not trigger, then current sensing device will not give pulse to the gate triggering circuit, and it will not fire the SCR. If value of current is more than rated value, or it is a faulty current, then this current sensing device will detect the fault. It will give pulse to the gate triggering circuit. So this gate triggering circuit will trigger this SCR. If the SCR will trigger, then whole current will pass through this fuse SCR, and again it will come back to negative point, and fuse will blow off. So this is how we can provide overcurrent protection by using one power electronic device, that is SCR. Let's see the question for assignment. The first question is explain di by dt protection. Second is explain d by dt protection, and the last is explain electronic crowbar circuit. Thank you.
If you like this video, please subscribe and like our YouTube channel LJP Electrical, and don't forget to click on the bell icon to get latest video update fast.